Welcome to AI News Digest 2026-06-10. Today's 9 stories. Story 1, Deployment Time Memorization in Foundation Model Agents. Story 2, Less Context, Better Agents, Efficient Context Engineering for Long-Horizon Tool-Using LLM Agents. Story 3, From Senses to Decisions, The Information Flow of Auditory and Visual Perception in Multimodal LLMs. Story 4, RealMath-Eval, Why SOTA Judges Struggle with Real Human Reasoning. Story 5, From Context-Aware to Conflict-Aware, Generalizing Contrastive Decoding for Knowledge Conflict in LLMs. Story 6, Supervised Fine-Tuning with Synthetic Rationale Data Hurts Real-World Disease Prediction. Story 7, Self-Distillation Policy Optimization via Visual Feedback, Bridging Code and Visual Artifacts. Story 8, Google's AI feature on hold in most EU member states due to strict rules. Story 9, Regimes. An auditable, held-out gated improvement loop demonstrated on LongMemEv with ActiveGraph. Story 1, Deployment Time Memorization in Foundation Model Agents. Imagine an AI system that can fix its own mistakes, not just in the moment, but in a way that's fully traceable, replayable, and validated before any change goes live. That's the core promise of a new paper called Regimes, published in June 2026 by Yohei Nakajima on Archive. And it's worth paying attention to because the approach tackles a problem that most autonomous AI frameworks quietly sweep under the rug. Here's the issue. When AI agents improve themselves today, the process is usually messy. Failures get logged somewhere external. Patches get applied by a separate script. Decisions about what to keep and what to throw away end up in a side database that the agent itself never sees. It's like a doctor performing surgery with no record of what was cut, what was sewn, or why. Nakajima's solution is to borrow a concept from distributed systems engineering called event sourcing. The idea is that every single thing the agent does, every failure, every diagnosis, every proposed fix, every acceptance or rejection gets written to an append-only event log. The agent's entire state is just a projection of that log. That means you can replay any run exactly as it happened. Nothing is lost. Nothing is hidden. The framework is demonstrated on a benchmark called LongMemEv, which tests how well AI systems answer questions requiring long-term memory. And here's where the research gets genuinely interesting. The team found that the dominant failure mode wasn't what most people would expect. It wasn't that the system couldn't find the right information. The information was already sitting in the context window. The problem was that the model failed to correctly reason over it, a reconciliation failure, not a retrieval failure. That's a significant finding for anyone building memory-augmented AI systems, because it suggests that improving how the model reads and synthesizes context may matter more than improving how it searches. Using the Regimes loop, which proposes prompt-level repairs and gates each one through a 4-stage validation process including held-out evaluation, the system achieved accuracy improvements of 5 to 10 percentage points on 4 of 5 test splits. The authors are admirably honest about the statistical limitations. The 5 splits share the same pool of 500 questions, so they're not fully independent. The broader implication here is architectural. As AI regulation increasingly demands audit trails and explainability, a runtime that natively records every decision as a structured event isn't just a research novelty, it's a practical compliance substrate. Regimes points toward a future where AI self-improvement isn't a black box, but a first-class, auditable workflow. Story 2, Less Context, Better Agents. Efficient Context Engineering for Long-Horizon Tool-Using LLM Agents. Google's AI Overviews feature, the AI-generated summaries that appear at the top of search results, finally began rolling out in parts of Europe in late March 2025. But the launch was far from complete. The feature went live in just 8 EU member states: Austria, Belgium, Germany, Ireland, Italy, Poland, Portugal, and Spain, plus Switzerland. The rest of the European Union, including major markets like France, was left waiting. This partial rollout came 9 months after AI Overviews debuted in the United States and other countries around the world. And according to a senior Google executive quoted by Euronews, the reason is not technical, it is regulatory. The EU's overlapping web of tech rules, including the AI Act, the Digital Services Act, and the Digital Markets Act, has created enough legal uncertainty that Google held back the product rather than risk compliance violations across dozens of different national contexts. The executive was candid about the consequences. Quote, "The EU is behind when it comes to product innovation, and users in Europe will have a less good product experience," end quote. That is a striking statement from a company operating in one of the world's largest consumer markets. Google is not alone in this frustration. Meta, which also delayed launching its AI assistant in Europe due to regulatory disputes, said it took longer than they would have liked to navigate Europe's complex regulatory system. For France specifically, the situation is especially uncertain. Beyond EU-level rules, France has strict national legislation around neighboring rights and copyright that adds another layer of legal complexity for AI tools that aggregate web content. Whether AI overviews will ever launch there is, in the words of one Google official, not impossible, but not guaranteed either. What this story illustrates is a widening gap between the digital experiences available to consumers in the US versus Europe, specifically around AI-powered products. As AI becomes more central to how people search for information, conduct research, and run their businesses, a 9-month lag in access has real consequences. The EU's regulatory ambitions are well-intentioned, protecting users, ensuring algorithmic transparency, guarding against market dominance. But the cumulative effect of 3 overlapping frameworks is creating a compliance fog that discourages rapid innovation. Regulators in Brussels will need to reckon seriously with whether the current approach is achieving its goals, or simply pushing AI benefits out of reach for hundreds of millions of European users. Story 3. From senses to decisions. The information flow of auditory and visual perception in multimodal LLMs. Most enterprise AI tools today are good at following instructions. Give them a task, summarize this report, classify these transactions, draft this email, and they perform well. But they fall short when the goal is not a task but an outcome. Grow revenue by 15%, reduce customer churn, optimize the supply chain for the next quarter. That gap is what a new theoretical paper from Archive, submitted in June 2026 by Cecil Pang and Hiroki Siyama, attempts to address. The paper introduces the concept of a business world model, or BWM. The idea is borrowed from a well-established tradition in AI and robotics, where world models give autonomous agents an internal simulation of their environment. Robots use world models to plan movements, predict consequences, and make decisions without needing to physically test every option. The authors ask, what if we built something similar for business? A business world model, as they envision it, would encode the key elements of a business environment. The current state of the organization, how that state changes over time in response to actions and external forces, the constraints the organization operates under, the objectives it is trying to achieve, and the space of actions available to it. With these components in place, an AI agent could simulate alternative strategies, estimate their likely outcomes, and evaluate trade-offs before committing to any course of action. The framework brings together 4 types of building blocks: semantic data representations that capture what the business knows, probabilistic machine learning models that capture uncertainty, deterministic business rules that capture hard constraints, and an explicit action space that defines what the agent can actually do. The authors are upfront about what is and is not new here. They acknowledge that none of these components individually are novel. The contribution is in organizing them into a coherent, unified architecture specifically designed for autonomous business planning. This is a conceptual paper. There is no working prototype, no benchmark results. But its significance lies in articulating a clear target for what the next generation of enterprise AI could look like. Not tools that automate predefined tasks, but systems that pursue strategic goals with genuine planning and reasoning. Whether that vision is achievable in practice remains an open and important question. Story 4. RealMath-Eval. Why SOTA Judges Struggle with Real Human Reasoning. RealMath-Eval introduces a benchmark of 224 real-world high school exam responses to test whether LLMs can evaluate diverse human reasoning processes, not just solve math problems. Results show that even state-of-the-art LLM judges struggle significantly with this evaluation task, revealing a gap between benchmark performance and real-world applicability. This has important implications for LLMs judge paradigms and AI in education. Story 5, From Context-Aware to Conflict-Aware. Generalizing Contrastive Decoding for Knowledge Conflict in LLMs. This paper identifies a reliability bottleneck in RAG and augmented LLMs, conflicts between retrieved context and parametric, trained knowledge. Existing contrastive decoding blindly amplifies external context, overwriting correct internal knowledge when retrieval is erroneous. The proposed conflict-aware paradigm dynamically allocates weight between context and priors, improving factual reliability. Story 6. Supervised fine-tuning with synthetic rationale data hurts real-world disease prediction. This paper challenges a widely held assumption that synthetic rationale-based supervised fine-tuning improves LLM performance on clinical prediction tasks. Across 504 configurations for Alzheimer's disease prediction from longitudinal health histories, rationale-based SFD consistently hurt performance. The findings have significant implications for AI safety and responsible deployment of LLMs in healthcare. Story 7. Self-Distillation Policy Optimization via Visual Feedback, Bridging Code and Visual Artifacts. This paper addresses a core limitation of code-generating LLMs. They produce visual artifacts, charts, web pages, slides, without observing rendered output, leading to visually defective results. A self-distillation policy optimization approach using visual feedback is proposed to close this gap. This has direct practical applications for AI coding assistants and document generation tools. Story 8. Google's AI feature on hold in most EU member states due to strict rules. Google's AI Overviews, its search-integrated generative AI feature, has not been rolled out across most EU countries due to regulatory uncertainty around the EU AI Act and related rules. A senior Google executive confirmed the hold, highlighting how EU regulation is materially delaying practical AI product deployment. This is a significant development for the global rollout of consumer-facing AI products. Story 10. Regimes. An auditable, held-out gated improvement loop demonstrated on LongMemEv with ActiveGraph. This paper presents regimes, a framework for autonomous agent self-improvement using event-sourced agent runtimes that make the improvement loop auditable and trustworthy. Demonstrated on the LongMemEv benchmark, the system logs failures, replays diagnoses, and embeds promote-or-discard decisions within the agent's own history. Addresses a core trust and safety challenge in autonomous improvement loops for AI agents.